Howdy, Papa. We have been talking about the geologic history of Georgia and the eastern United States. And we're getting ready. We talked about the rifting of Rodinia supercontinent, and we talked about the tectonic mountain building event. Soon, I'm going to tell you about the Acadian mountain building event, which is the second big mountain building event, and then the Alleghanian mountain building event, which was the last mountain building event, and then finally we'll talk about the second rifting event, which was the rifting of Pangaea. But I keep going back to the rifting of Rodinia because I keep thinking of things I want to tell you about, and that's what we're going to do today. We're going to talk about Tallulah Gorge and the Tallulah Falls dome rocks and where they formed and how they got to be where they are today. But first I want to say hi to all you guys, my rock buddies now, and I just want to encourage you to please give comments if you to me. I love to get questions about rocks. I love to get questions about trees too. Tree ID. I'm getting ready to do a big bunch of videos on tree ID, so I love to hear your questions. I love to hear your comments. Even if you see things that are wrong, I want to help me get corrected. That would be wonderful too. Because Grammy and I we've just been sitting around here for almost a year, not going anywhere, and one of us is driving the other one crazy. So she would be happy if you would do something to keep me busy so I won't pester her. Anyway, let's talk about the Tallulah Gorge. So we're going to flip around and look at the map. Okay, let's look at the geological map. Once again, we're using the book Rocks of Georgia. You can get it on Amazon Books. Tallulah Gorge. Here we go. Tallulah Gorge is about where that green spot is right there, right in the crook of Georgia. That's pretty significant. Someday we'll talk about stream capture, but for now we're going to talk about Tallulah Gorge. You guys have probably been to Tallulah Gorge, I don't know, but it is a deep gorge cut into the rocks. It's quite deep. I don't know how many hundreds of feet deep it is, but it has very steep walls. It has a beautiful river down there. I guess it's the Tallulah River that flows over several waterfalls. You can hike down there and look at it. The steep canyon walls make unique habitats for unique creatures, and I think there's some creatures that live in the gorge that are very rare and unique to the gorge. So Tallulah Gorge, let's talk about its rocks. Tallulah Gorge is made out of rocks of the Tallulah Falls dome formation. And here is the Tallulah. See the number 3? And you can see it's surrounded by a kind of an oval. Well, that 3 is right smack dab in the middle of the Tallulah Falls dome formation. And all this green rock is part of that. And the Tallulah Falls dome, they call it a geologic dome because it's kind of like if you took an onion and sliced it off, and you get these circular layers around the edges and going toward the middle. That's what it is. It's kind of like that, but it's been twisted and mashed and folded like you wouldn't believe. It's very highly metamorphosed. So let's look at the rocks of the Tallulah Falls dome, the rocks that you find when you go down into Tallulah Gorge and on the sides of the gorge, and see what they are. I have made a list of them for you. I'm going to switch hands so I can use my left hand with the pen. Here are the rocks. Now, the geologists that figured all this out figured that these are the oldest rocks in the layers. And you go up here and you get to younger rocks. Oldest rocks, youngest rocks. So let's start with the oldest rocks. Ultramafic rocks. You know, ultramafic rocks are examples like peridotite and dunite. And where do you find them? You find them right at the top of the molten mantle, or you could say you find them right at the bottom of ocean crust. So we've got a clue there. Next up, we've got greywacke and amphibolite. Let's look at amphibolite. Amphibolite is a metamorphic version of either basalt lava and or gabbro-pluton. If you remember, basalt lava and gabbro-pluton are chemically and minerally exactly the same thing. It's just that the gabbro-pluton stays underground and the basalt lava gets erupted out. So if it's underground, it's called gabbro. If it erupts above ground or above the bottom of the ocean into the water, it can be underwater, it's called basalt. Okay, so that's interesting, amphibolite. What is ocean crust made out of? Voila, ocean crust is made out of a layer of basalt lava, and underneath that a layer of gabbro-pluton, and way underneath that a layer of ultramafic rocks. So what are we looking at with this and this? We're looking at ocean crust, former ocean crust. Now let's look at this greywacke. And see, we've got 2 layers of greywacke. And so what is greywacke? I'm just going to call it greywacke. If you remember when we talked about the rifting of Rodinia and the big rift basins or rift grabens, like what you find at Great Smoky Mountains National Park, and you do find them here in Georgia, for example, Fort Mountain State Park would be a good place to see them. You're looking at greywacke, you're looking at turbidite. Greywacke is a turbidite sediment. Turbidite means that this material that was pebbles, rough-sided pebbles, sand, silt, and clay all mixed together got washed into a deep basin very quickly. And the sizes are all mixed up. So if you're looking at greywacke, you're looking at a kind of a matrix of sand, silt, and clay. And embedded in that matrix, again, like raisins in a muffin, are hunks of quartz, hunks of feldspar, hunks of other rocks. And if those hunks are about the size of Honest Abe's ear, we call it greywacke. If they're the size of his head, then I call it turbidite sandstone, just to keep it from being confused with regular equigranular sandstone. You could call it all greywacke. You could call it Abe's head greywacke or Abe's ear greywacke, whatever you wanted to. So where do you find greywacke? Yeah, you find it in rift grabens, but you also find it on continental slopes. That's where the shallow continental shelf under the ocean, at the edge of the continent, drops off steeply down to the ocean depths. So we've got ocean crust, we've got continental slope deposits, and here is just garnet aluminous schist. This is just mud. Here we have some more greywacke schist, and that's turbidite. So this is all probably the continental slope plus a little of the continental shelf. And then up here at the top, we've got quartzite and schist. Well, quartzite, is metamorphosed sandstone. And what is sandstone? It's just sand grains mashed into sand. So we're looking at the beaches, the coastal plain, the beach, and the continental shelf here. So that's pretty straightforward, but let's look at a picture that I drew of it all to help explain it. Here's the continent, edge of the continent. This is water. This fungi line look be water. Here's the ocean bottom way out here. This is where you would find, let me tell you about this. This is that rifted hunk. This is right after Rodinia rifted. This rifted hunk was attached here. It rifted off and went out away from the edge of the continent. How many miles, I don't know. But if you look at the Sea of Japan, the Sea of Japan is exactly like this, and the Japanese islands are exactly like this, except they are actually volcanic, and this hasn't become a volcanic island yet. It did in Taconic, but we're still just after Rodinia rifted. Okay, so you've got kind of going this way. You've got continental shelf deposits out here, and then the continental slope, and then the deep ocean. So these would be your Tallulah Falls dome rocks. Continental shelf, continental slope, and ocean. So that's where they came from. Let me show you. As you know, when the Taconic mountain building event came, The ocean crust broke and subducted under this hump that had been turned it into a volcanic island, right? Here are those Tallulah Falls dome rocks. They were kind of pushed up and mashed and experienced a lot of metamorphism at that time, but there was more metamorphism to come. Okay, so let's go back and look at them here. And where did it go? Where did it go? Where did it go? Oh, here we go. So Tallulah Falls dome rock here and down in here. They're so squirreled up, and they're, to me, now I may be wrong about this, and if you're a well-informed geologist and know differently, please give me a comment and straighten me out. But here's the Brevard Fault Zone. And we're pretty sure that all of this land right here used to be further northeast and slid down here like this along this Brevard Fault Zone. When did that happen? During the Acadian mountain building event, and I'll tell you more about it. I believe that Tallulah Falls dome rocks were mashed and thinned and domed up and slid and smeared during that process. See how this looks smeared out? I think these rocks were severely smeared and sheared in the Brevard Fault Zone as all this inner Piedmont and Carolina terrain slid down from, North Carolina, Virginia area. And I think it enhanced the metamorphism that occurred in these rocks. And when you look at Tallulah Falls dome rocks, they look very crystalline, and that's a sign that they've been heavily metamorphosed. Okay, so what we've learned today is that the right after Rodinia rifted, and the piece of land crust rifted off from the mainland of Proto-North America and drifted out into the ocean, the newly formed ocean. Then erosion took place and a continental shelf, continental slope, and deep ocean basin formed, mostly to the east, to the ocean side of that rifted hunk. Everything is calm, everything is peaceful, but the tectonic mountain building event is coming, and we've already talked about that. But I wanted you to know that about these Tallulah Falls dome rocks, so that when you go to Tallulah Gorge, you can look at them and know how we got them. So that's it for today, but I just want to remind you that, number one, you are my rock buddies, and I want you to have a great day. This COVID is going to be over sometime. Excuse me. And also, please give me comments. I love them. All right, Papa out. Whoops.